Hi everyone, my name is Yingyi Wang. I'm a PhD student from the University of British Columbia. I work with Marco Xia and Professor Julia Rubin at UBC, and also with Yikang Chang from IBM on the project to develop automated analysis tools for microservice-based apps. Microservice is an architectural style to build complex applications as a composition of small, loosely coupled components that encapsulate individual business capabilities. One application can consist of numerous microservices that are highly distributed and communicate with each other over the network, synchronously or asynchronously, which makes identifying bugs and security vulnerabilities more challenging than in monolithic apps. The goal of our project is to help developers identify such bugs early in the lifecycle at development time by relying on static code analysis techniques. Here is an example of a simple master call between classes in a monolithic application. The full function in the sender class calls the bar function in the receiver class. Now, if I change the parameter from string to integer, the compiler will complain of a mismatch type when calling the bar function from the full function before you run your application. Now, let us change this into two microservices, and they communicate with the REST API between these two classes. The full function in the sender service still calls the bar function in the receiver service. But now the compiler will not complain about a mismatch type because they communicate over the network and are not built together in one executable. So we do not know about the type for each parameter and compare if they're the same or not. However, the type mismatch of requested parameter will lead to a runtime error. This broken API contract is just one example of an issue that we want to identify pre-deployment before they occur at runtime and in production. Other issues include security vulnerabilities such as SQL injections, non-pointer exceptions, and buffer overflows. In our work, we are developing a tool to perform static code analysis of microservice-based applications. Code analysis tools have been extensively studied for monolithic applications, but solutions for microservices are not well explored. Most code analysis tools rely on an accurate representation of an application call graph, as well as its control and data flow graph. So far, we have developed a prototype call graph construction tool for the Spring framework, which is a popular framework for building microservices. Our tool will analyze Spring annotations and configuration files to identify communication between microservices. Besides the code analysis work, the second part of our work is to empirically identify the most frequently occurred issues in microservice-based apps. Towards that end, we are collecting open source applications that are developed using the microservice architectural style. Then we are manually analyzing the failures of these applications to identify the most frequent issues or microservice-specific vulnerabilities that developers need support with. As next steps, we plan to extend our call graph tool to support more microservice-based apps, for example, those that are developed with microprofile. Second, we plan to build a taxonomy of issues and security vulnerabilities that are specific to microservice-based apps. Then we plan to develop static analysis techniques to automatically identify and further fix the most challenging and frequent issues, making use of our call graph tool. Thank you for listening, and please feel free to contact us for more information.